Have you ever felt completely, well, swamped by the sheer volume of information you need to consume just to stay current? Especially in a field like software development, it moves so
Oh,
fast.
absolutely. Keeping up, making informed decisions. It can feel like trying to drink from a fire hose, right? Where the more you try to absorb, maybe the less you actually retain.
Exactly. It's not just about knowing what's new, is it?
No, it's understanding why it matters, how it all fits together, and crucially, how to filter the noise from what's genuinely impactful. That's the real challenge, I think.
That's precisely our mission here on the deep dive. Today, we're embarking on a, well, pretty ambitious exploration into the fundamentals of software architecture. We're drawing insights from that incredibly comprehensive work by Mark Richards and Neal Ford.
Great book.
Yeah, and our goal is to extract those crucial nuggets, maybe some surprising facts, and definitely actionable insights. Stuff that gives you a significant shortcut to being genuinely well informed about this complex world.
And it's not just about what an architect does, but why their role is so vital, isn't it?
Absolutely, and how their decisions shape the very systems we interact with every single day.
So, yeah, we've taken a deep dive into the core concepts, the evolving roles, the challenges, and those diverse architectural styles they present.
It's lauded, rightly so, I think, for condensing decades of experience into an invaluable resource.
Definitely helps distill those crucial strategic frameworks for you.
Okay, so let's unpack this. Starting with the architect themselves, defining software architecture and the software architect role. It's famously difficult.
Oh, yeah.
Martin Fowler, big name in the field, he famously refused to even try and define it. Why is it so elusive, do you think?
Well, the field is just incredibly dynamic. It's constantly evolving. Um, any definition from just a few years ago might already feel outdated.
Right.
Think about how rapidly we moved, say, from monoliths to microservices. Each shift like that fundamentally changes what architecture even means in practice. So the core insight, I think, is that architecture isn't some static blueprint. It's more like a living, breathing set of decisions that has to adapt to continuous change.
Okay, so given that fluidity, what do Richards and Ford argue are maybe the least obvious yet most crucial expectations for an architect? Things listeners might not immediately think of.
Well, beyond the obvious technical skills, they highlight 8 core expectations. And two that really stand out to me are the need for strong interpersonal skills and, crucially, the ability to navigate organizational politics.
Ah, politics. Always there.
Always. Architects aren't just technical wizards. They have to be communicators, negotiators, leaders. You can have the most brilliant technical solution, but if you can't articulate it, sell it, get buy-in from all sorts of different stakeholders, well, it's basically useless.
That's a really powerful distinction. It sounds like a lot of plates to spin.
It is.
So how does architecture interact with other critical areas, like, say, engineering practices or operations, DevOps?
Yeah, the relationship there has really matured. What maybe was once seen as more of a craft has evolved, definitely, into more of an engineering discipline.
Okay.
And that's thanks to advancements like, extreme programming, agile methodologies. These practices introduced more rigor, repeatability, effective analysis into development.
Which directly impacts design.
Directly impacts how architects design systems.
Yeah.
And for operations, the relationship transformed too. From something purely contractual, maybe, to something far more symbiotic.
Symbiotic, how so?
Well, this shift is crucial, especially when you think about concepts like elastic scale.
Ah, you're referring to the famous pets.com story, aren't you? How did that specific disaster, how did it catalyze something as fundamental as cloud elasticity?
It's such a classic lesson. Pets.com had this overwhelming Christmas rush, right? And it completely choked their infrastructure. They basically had too much success, too fast, and their systems just couldn't scale. And that real-world failure really highlighted the critical need for systems to rapidly adjust to unpredictable load. It drove the innovation we now kind of take for granted in cloud elasticity.
Right. We just expect it now.
We do. It showed everyone that operational concerns aren't afterthoughts. They're core architectural decisions. And similarly, development processes like agile foster faster feedback loops. That allows architects to be a bit more aggressive with experimentation, making those big architectural decisions less of a, one-shot gamble.
It's clear then that data isn't just something to be stored, but it's an active participant in architectural decisions.
Absolutely.
And speaking of design choices, how do we even begin to define what makes a successful system beyond just its core functions? Which leads us, I think, directly to the concept of architecture characteristics. often called the ilities.
Yeah, they're ilities, like performance, scalability, security, maintainability. They are indeed the success criteria of a system. And importantly, they're orthogonal to functionality.
Orthogonal, meaning separate concerns.
Exactly. Architects distinguish between explicit characteristics, those clearly stated in requirements, like the system must handle 1,000 transactions per second, and implicit ones.
Right, implicit characteristics. Those often go unstated, but are absolutely necessary. Like for your silicon sandwiches example.
Yes.
The requirements might not explicitly say availability or elasticity, right? But a sandwich shop definitely experiences traffic bursts around lunchtime, so the system has to handle that.
Precisely. And then there's the fun one you mentioned, italybility.
Italybility, explain that one.
Well, it's that unique, problem-specific characteristic that sometimes emerges, perhaps tied to what Richards and Ford call a frozen caveman scenario,
Okay.
where an architect clings to an outdated, maybe even irrational concern based on some past trauma. Like a system designer continually asking, but what if we lose Italy when the chances are just infinitesimally small?
So it's about past baggage influencing design.
Exactly.
Yeah.
It's a humorous way to highlight how implicit and even irrational concerns can shape design. And to help aspiring architects practice identifying these characteristics, they suggest architecture katas.
Katas, like in martial arts?
Kind of. They provide domain-specific problems for design exercises. Great practice.
That sounds brilliant. Okay, so once you've identified these characteristics, how do you measure them? And crucially, how do you govern them to make sure they're actually being met by the development teams?
Right. Measurement and governance. You need concrete measures. For performance, for example, it's not just average response time you care about. You must also measure maximums to catch those outliers.
Good point.
But more fundamentally, we use what are called architecture fitness functions.
Fitness functions. Okay.
These are basically any mechanism that provides an objective assessment of some architecture characteristic. It's not really a new framework, more like a new perspective on tools we might already have.
Can you give us some practical examples? How do these work in action?
Absolutely.
Yeah.
You could have automated checks for cyclic dependencies using tools like JDepend or ArchUnit. That ensures modules don't create those problematic circular relationships.
Right.
Or layer verification, preventing, say, a presentation layer from directly accessing the database. You can enforce that with tools like NetArchTest. But for a really fascinating real-world example, you have to look at Netflix's Simian Army.
Ah, the Simian Army. That sounds like a perfect illustration of automated governance actually working in production. What does each monkey do?
It's a fantastic example of proactive governance, born from Netflix's move to the cloud and their need to really control operations at scale. It includes things like
Go on.
Chaos Monkey. This one deliberately simulates failures, randomly shuts down services, instances, forces engineers to build resilient systems from the ground up.
Trial by fire.
Literally. Then there's Conformity Monkey. This ensures governance rules are followed right there in production. It might check that services respond to all RESTful verbs correctly or adhere to naming conventions, that kind of thing. Security Monkey actively checks for security defects and vulnerabilities, finding misconfigurations or insecure practices before they can be exploited.
Proactive security.
Exactly. And finally, Janitor Monkey. This one finds and removes orphan services or unused resources that aren't routed to anymore, saves cloud costs, reduces clutter.
That's incredible. So it's basically operationalizing fitness functions, ensuring architects' decisions are continuously validated right there in the live environment.
That's a great way to put it.
It really underlines the importance of how components are, wired together.
It does.
Which brings us neatly to coupling, connascence, and the architecture quantum. How do these concepts connect?
Well, coupling is a familiar term, right? But Myler Page Jones refined it with this idea of connascence.
Connascence.
Yeah, it means a change in one component would require the other to be modified to maintain correctness. It's a deeper way of describing how things are sort of inextricably linked.
Okay, so stronger than just coupling.
Maybe more precise. And this leads directly to the crucial concept of the architecture quantum.
What exactly is the architecture quantum? Why is it so critical?
It's a really fundamental measure. It defines the scope of those architecture characteristics we talked about, the ilities. Think of it as the smallest deployable unit of code that can exhibit all of its required architectural characteristics independently.
Smallest deployable unit with all its characteristics. Okay.
Yeah. It helps architects understand which components are so tightly wired together, meaning a change in one ripples significantly to the others, that they must share the same architecture characteristics, and therefore they belong in the same quantum.
I see.
And this concept fundamentally drives that big decision: monolithic versus distributed architecture. If multiple components can operate independently with different characteristics and be deployed separately, then you're looking at a distributed system with multiple quanta.
It sounds like understanding quanta is really key to truly breaking free from a monolith, if that's your goal.
A very powerful lens, yes.
And speaking of monoliths, architecture styles have certainly come a long way from what's famously known as the big ball of mud.
Haha, yes, the big ball of mud. Haphazardly structured code, no discernible architecture. We've all seen them.
Probably worked on a few.
Possibly.
Mhm.
Early on, we had more fundamental styles like two-tier systems, right? Desktop app talking to a database or a browser to a web server.
Simple times.
Simpler, maybe. Then came the three-tier architectures in the late 90s, introducing application servers, protocols like Corba.
Right. Corba, decom, memories.
Exactly. It
Yeah.
was a step forward, but these systems quickly hit a wall when they faced the realities of distributed computing.
And here's where it gets really interesting, I think. The 8 fallacies of distributed computing.
Ah, yes, the fallacies. Crucial.
These are those commonly ignored assumptions that just inevitably lead to problems in distributed systems, often learned the hard way by developers, right?
Very often the hard way. Let's tackle a few of the most impactful ones. First, the network is reliable.
Big one.
Huge, which is a dangerous assumption. In reality, networks are inherently unreliable. Components, services. They will fail. Ignoring that means your system will crash when they do. You absolutely must design for failure.
Okay, fallacy number 1. Network unreliability. What's another critical one?
Number 2, latency is 0.
Often overlooked, right?
Critically overlooked. Local calls inside a process are measured in nanoseconds. Remote calls, even on fast networks, are in milliseconds. That's orders of magnitude slower.
Nanoseconds versus milliseconds. Huge difference.
Massive. Most architects, frankly, ignore this, but it adds up incredibly quickly in complex distributed systems. It leads to those frustratingly slow user experiences. You know, if you're building a system, you really should know your average network latency between services and production. Most don't.
Good metric to track. Okay, third fallacy.
Bandwidth is infinite. This one can hit you hard, especially on the cloud bill.
Ah, the cost aspect.
Absolutely. Bandwidth is a finite, often pretty expensive resource. Imagine a wish list service calling a customer profile service. And that profile service returns, say, 500 kilobytes of data when the wish list only needed maybe 200 bytes.
Wow, huge overhead.
Right. And maybe this happens 2,000 times a second under load. That's suddenly a gigabit per second of bandwidth for just one inter-service call.
Yeah.
That's a form of coupling called stamp coupling.
Stamp coupling.
Yeah, where services unnecessarily exchange way too much data, often an entire data structure, when only a tiny portion is actually needed. Very inefficient.
Wow, that's a direct hit on performance and cost. Okay, these fallacies are sobering. Let's shift to a style designed to handle some of these distributed challenges, especially unpredictable loads, space-based architecture.
Right, space-based. This style is really designed for extreme scalability, elasticity, and those unpredictable bursts of load. Think concert ticketing, online auctions, that kind of thing.
How does it work?
It uses what are called processing units. These encapsulate the business logic and often include in-memory data for ultra-fast access.
In-memory data, okay.
Yeah, and these units operate with virtualized middleware that handles things like data grids, messaging grids, processing grids, allowing them to scale out horizontally almost effortlessly. Asynchronous data pumps then update the main database in the background.
So it pushes data close to the logic.
Exactly. It's truly designed for multiple quanta, minimizing those network hops we talked about with latency.
Very interesting. And what about today's arguably most popular choice, microservices architecture? What's the core philosophy driving it?
Microservices.
Yeah.
Very popular. It's heavily driven by the bounded context concept from domain-driven design.
Bounded context, meaning?
Meaning each service models a specific business domain or workflow. This naturally leads to strong data isolation and, crucially, a preference for data duplication over tight coupling. It pushes back against that old canonical representation idea where one service owns all the customer data, for example.
Right, avoiding that single point of failure or bottleneck.
Precisely. And the term microservice itself, it's really just a label, not a strict size commandment. Service granularity is often better determined by things like transaction boundaries.
Okay.
It leverages operational reuse with things like service meshes and service discovery for common concerns. And front ends can be either monolithic UIs or, increasingly, micro front ends.
How do microservices typically communicate? And what's that really crucial piece of advice Richards and Ford give about transactions across services?
Communication can happen via choreography, kind of like a broker-based, event-driven architecture with no central coordinator, or through localized orchestration, where one service might act as a mediator for a specific workflow involving a few others.
Choreography versus orchestration.
Right. And here's that key advice. It's blunt. The best advice for architects who want to do transactions across services is don't. Fix the granularity components instead.
Wow.
Just pretty much. It emphasizes designing your services so that critical business transactions can complete within the boundaries of a single service whenever possible. Avoids the massive complexity of distributed transactions.
Makes sense. So microservices excel in scalability, elasticity, evolution.
Definitely. Supports a faster rate of change for businesses, which is often the key driver.
So given all these different styles layered, pipeline, microkernel, service-based, EDA, space-based, SOA, microservices, what's the profound insight into actually choosing the appropriate style? It feels overwhelming.
It can be. But the profound insight, I think, isn't just knowing the styles themselves. It's understanding that the best choice is rarely about pure technical superiority and isolation.
Okay.
It's much more about aligning your systems architecture with your organization's capabilities, your team's dynamics, and your current business needs. You have to consider external factors like performance requirements, internal factors like team structure and experience, data requirements, all of it.
Context is everything.
Context is absolutely everything. And a good guiding principle they often advise is use synchronous communication by default, asynchronous only when necessary. It's generally simpler and more predictable to start with.
Synchronous default, async when needed. Got it. Now, the journey of a software architect is just filled with crucial decisions, and it sounds easy to fall into traps. What are some common architecture decision anti-patterns you see?
Oh, there are a few classics. First, covering your assets.
Sounds familiar.
Yeah, it's basically avoiding or deferring decisions out of fear of being wrong. You overcome this by waiting for the last responsible moment when you have just enough information to make an informed choice, but no later. And by collaborating closely with development teams, sharing the risk and the decision.
Okay, don't delay out of fear. What's number 2?
Groundhog Day.
Like the movie.
Exactly like the movie. It's endlessly rediscussing decisions that have already been made and agreed upon. It just saps team energy and productivity like nothing else.
Ugh. Yeah, been there. And third.
Email-driven architecture. This happens when important decisions get communicated informally, maybe buried in email threads, or just poorly. It leads to multiple inconsistent systems of record for that decision, breeds massive confusion and rework down the line.
Okay, those are definitely pitfalls. So how do you fix these anti-patterns? How do you ensure good decisions are made and actually stick?
Well, one of the most effective ways, championed by folks like Michael Nygaard and ThoughtWorks, is using architecture decision records, or ADRs.
ADRs. Tell me more.
They're essentially short, concise text files, usually just marked down, that describe one specific architecture decision. Simple idea, really powerful.
What's their basic structure? Why is each part important?
Okay, so an ADR typically has a title, obviously. A status like accepted, maybe superseded by a later ADR, or request for comments if it's still a draft.
Right.
Crucially, it includes the context. This explains the forces at play, the problem you're trying to solve. It paints the picture of why this decision was even needed in the first place.
Sets the stage.
Exactly. Then comes the decision itself. Stated clearly, usually in an affirmative commanding voice like, we will use asynchronous messaging for order processing.
Clear and direct.
Yep. And finally, maybe most importantly, it details the consequences. This includes both the good and the bad impacts and explicitly calls out the trade-off analysis. What did we gain, what did we lose or accept by making this choice?
So it's not just what was decided, but why, and crucially, what the impact will be. That sounds like it would definitely help avoid that Groundhog Day problem.
It absolutely does. ADRs also emphasize including a business justification. How does this decision impact cost, or time to market, or user satisfaction? It connects the tech to the business,
Nice.
and they drastically improve communication. You get a single source of truth, and you can do targeted notifications only tell the people directly impacted by this specific decision.
And you mentioned fitness functions earlier.
Right. Fitness functions can even be used to automatically check and ensure compliance with the decisions documented in ADRs over time. keeps the system aligned with a documented architecture.
That's a powerful feedback loop. Okay, that brings us naturally to analyzing architecture risk. Decisions involve risk. How do you objectively qualify risk in a way that's easy to understand and communicate?
A really useful tool is the risk matrix. It's usually a simple two-dimensional grid. You multiply the potential impact of a risk. How bad would it be if it happened?
Yeah.
By its likelihood. How likely is it to
Or
happen?
impact times likelihood.
Exactly. And that gives you a qualitative score, low, medium, high. Simple, visual, effective for prioritizing. These matrices then feed into risk assessments.
Which are?
Summarize reports of the overall architecture risk. They track trends over time, maybe using little arrows to show if a particular risk is getting better or worse based on mitigation efforts.
You can see progress.
You can. And for a more collaborative approach to actually uncovering risks in the first place, there's a technique called risk storming.
Risk storming sounds energetic.
It is. It's a powerful collaborative process, gets the whole team involved. Starts with individual brainstorming. Everyone silently writes down risks they see. Then you move to a collaborative consensus phase. Discuss, group, prioritize the risks together. And finally, a mitigation phase. What are we going to do about the top risks?
Can you give an example?
Sure. Imagine designing that nurse diagnostic system we mentioned. In risk storming, the team might identify risks related to, say, availability during peak hours, or elasticity if patient load suddenly spikes, or security of patient data. Then they'd collaboratively figure out mitigation strategies, maybe analyzing service-level agreements more closely, strategically breaking down a monolithic database to reduce single points of failure, or adding specific security measures.
Very practical. Okay, it's clear that no matter how technically brilliant an architect is, if they can't communicate their ideas effectively, they probably won't get very far.
Absolutely true. Soft skills are paramount.
So let's shift gears slightly to communication and leadership for architects. What's really key here?
Well, first off, mastering visual communication through diagramming is just critical for shared understanding. You really need to hone your skills with diagramming tools, focusing on features like layers, stencils, magnets, things that help create clean, professional, and unambiguous diagrams.
Right. Good diagrams make a huge difference. And visual guidelines matter too, don't they?
Definitely. Things like consistent line thickness, clear arrowheads, maybe using dotted lines for asynchronous communication versus solid for synchronous. Consistent shapes, clear labels, sensible use of color, always including a key or legend.
I appreciate the warning in the book against the irrational artifact attachment anti-pattern.
Yes. Don't get too attached to those early, maybe low-fidelity diagrams just because you spent ages making them look pretty.
Guilty as charged sometimes.
We all are. It's a key insight. Iterate on the design first, then invest time in polishing the diagram once the ideas are more stable.
Good advice. Beyond static diagrams, effective presentations are also key, right?
Absolutely. And presentations are more than just slides. They're about effectively manipulating time, using transitions, animations, incremental builds to unfold ideas logically, maintain suspense, and guide the audience through your narrative.
So definitely avoid the bullet-riddled corpse anti-pattern.
Please, that's where slides are just a wall of dense text. Awful. Instead, use those incremental builds to reveal points one by one, keeping the audience engaged.
And remember the distinction. Slides are half of the story.
Exactly. An info deck is designed to be a standalone document. But a true presentation needs the speaker to deliver the other crucial half of the content. These skills are absolutely essential for architects to rally support for their vision and decisions.
But it's not just about technical communication, is it? It's also about making teams effective, which really touches on the human side of architecture.
Very much so. Architects need to find the right balance of control within their teams. Richards and Ford describe three sort of archetypal architect personalities.
Right, the control freak.
Who imposes really tight boundaries, dictates far too much detail. Then there's the armchair architect.
The opposite.
Exactly. Provides too little guidance, lets things drift, maybe isn't hands-on enough. And then the ideal, the effective architect.
Who finds the sweet spot?
Finds just the right boundaries. Balances necessary control with team autonomy. And that balance is influenced by lots of factors, right? Team familiarity, team size, experience level, the complexity and duration of the project. It's a really nuanced dance.
And this dance gets even more complex when you encounter certain team warning signs, like process loss.
Yeah, process loss, also known as Brooks' Law. Brooks famously stated, adding manpower to a late software project makes it later. The more people you add, especially beyond a certain point, the more communication overhead, coordination problems.
Frequent, painful merge conflicts are often a good sign of this, they say.
That's a classic
Yeah.
symptom, yeah. Then there's pluralistic ignorance.
The emperor's new clothes phenomenon?
That's the one, where individuals privately doubt something. Maybe a design decision or the project's direction, but because nobody else speaks up, they assume everyone else agrees, so they stay silent too. Publicly conforming while privately doubting.
Dangerous.
Very. An architect needs to actively facilitate open, honest discussion to unearth these hidden doubts before they cause major issues.
And the third warning sign, diffusion of responsibility.
This tends to happen as team size increases. Clarity on who exactly is responsible for what starts to decrease. They use the analogy of a broken-down car on a busy highway.
Everyone assumes someone else has already called for help.
Exactly. So nobody does. Architects need to ensure clear roles and responsibilities are assigned and, crucially, understood by everyone on the team.
Okay, those are significant challenges. What about simple practical tools? They talk about leveraging checklists. Seems almost too simple.
They're deceptively powerful, especially for those error-prone or often missed tasks. 3 key ones they highlight are a developer code completion checklist, a unit and functional testing checklist, and a software release checklist.
What kind of things go on them?
Even obvious stuff, like did you run the code cleanup tool? Have all new database scripts been reviewed? Things that get missed in the rush without a concrete reminder.
Makes sense.
But beware the Hawthorne effect, where people change their behavior just because they know they're being observed, or in this case, checked. You need to ensure people actually use the checklists meaningfully, not just tick the boxes mindlessly. Keep them concise and genuinely actionable.
These points really speak to the crucial human side of architecture, and that ties directly into negotiation and leadership skills, doesn't it?
Absolutely critical skills for any architect, especially when dealing with business stakeholders. For instance, negotiating whether a system truly needs, say, 5 nines of availability versus maybe 3 nines.
Which sounds small, but the difference is huge, right?
Massive. 5 nines is about 5 minutes and 35 seconds of downtime per year. 3 nines is nearly 8 hours and 46 minutes. The cost and complexity difference to achieve 5 nines is enormous. An architect needs to be able to translate those technical demands into tangible business terms. Cost, effort, risk, and use techniques like divide and conquer to break down vague or excessive demands.
And what about negotiating with developers? You mentioned earlier it's about negotiation, not dictation.
Absolutely vital. Don't just say, you must go through the business layer to access the database. That breeds resentment. Instead, ask, have you considered using a cache here? It might give us the performance we need without adding complexity in this spot. Always provide the justification, the why.
Frame it collaboratively.
Yes. And sometimes, especially during really busy periods, you might even frame a request as a favor. You know, could you do me a favor and look into this approach? It helps gain buy-in when people are stretched thin.
It all points to the idea that the software architect is ultimately a leader.
Very much so. They need to embody what Richards and Ford call the C's of architecture: clarity, courage, compassion, conciseness, communication, and appropriate control.
Nice list.
Yeah. And a key part of leadership is distinguishing between essential complexity, the inherent difficulty of the problem domain itself. We have a hard problem, and accidental complexity. That's the complexity we introduce through poor design, bad choices, or overly complicated implementations. We have made a problem hard. As Neal Ford often quips, developers are drawn to complexity like moths to a flame. So a leader needs to steer the team away from unnecessary complexity. They lead by example, gain respect through competence and collaboration, and even use grammar strategically, saying what you need to do is shuts down discussion, whereas have you considered fosters collaboration.
Subtle but important differences. Okay, as we start to wrap up this deep dive, it's overwhelmingly clear that technology changes at just a dizzying pace. They pose the question, has any group in history learned and then had to throw away so much detailed knowledge as software developers? It's a really compelling thought.
It really is. And it's why continuous learning isn't just, a suggestion for architects. It's an absolute necessity for survival and relevance. Architects must actively develop a kind of personal radar for technology.
When you talk about a personal radar for technology, what kind of framework or mental model are you suggesting listeners adopt? Is it like the ThoughtWorks technology radar, or is it more informal?
It's very much in the spirit of the ThoughtWorks tech radar. Yeah. That model categorizes technologies into 4 useful quadrants: tools, techniques, platforms, and languages. And within those, it uses 4 rings. Hold stuff to actively avoid or move away from, assess things that look promising, worth investigating, trial things you should be actively doing R&D on, maybe proof of concepts, and adopt technologies that are considered current best practices, ready for mainstream use.
Okay. Hold, assess, trial, adopt.
The crucial insight here, I think, is to treat your personal technology portfolio like you would a financial one. Diversify. Don't put all your eggs in one trendy basket. Actively manage it. Don't just pick what seems cool right now. Understand where it fits on your personal radar based on your context and goals.
That's a great analogy. And how can something like social media play a constructive role in this, beyond just, keeping up with tech news headlines?
Well, there's interesting work like Andrew McAfee's research on social networks that highlights the importance of weak links.
Weak links.
Yeah, these are your casual acquaintances, connections outside your immediate professional or social circle. These weak links are often the source of novel information, new job opportunities, and genuinely valuable insights precisely because they operate outside your usual echo chamber.
So they expose you to different perspectives.
Exactly. Using social media professionally, platforms like LinkedIn, maybe Mastodon, even curated Twitter lists to deliberately build a diverse network of respected technologists you can learn from. That's a fantastic way to keep your personal radar fed and truly broaden your perspective.
Makes sense. So bringing it all together, what's the parting advice from Richards and Ford for those listeners looking to really excel in this constantly evolving field of software architecture?
It circles right back to that quote from Fred Brooks. How do we get great designers? Great designers design, of course, and then Ted Neward's apt follow-up specifically for architects. How are we supposed to get great architects if they only get the chance to architect fewer than a half dozen times in their career?
The answer has to be practice then. Deliberate practice.
Exactly. You can use those architecture katas we mentioned. They're available on the book's companion website. They let you continuously hone your design and decision-making skills by tackling realistic architectural problems, even if you're not the lead architect on your current project.
Practice, practice, practice.
And always, always remember that core philosophy. There are no right or wrong answers in architecture-only trade-offs. It's fundamentally about understanding the why behind your decisions, not just the how, and making the most informed choices possible for your unique context. Analyze those trade-offs.
Fantastic. Well, we've certainly explored the multifaceted world of software architecture today, from trying to define the role and its core concepts, through navigating all those diverse architectural styles, making critical decisions, managing risk, and even mastering essential soft skills. Hopefully, you now have a clearer map to navigate this complex terrain.
And now, maybe for a final provocative thought to leave you with. We talked about the architecture quantum, defining the scope of architecture characteristics for a deployable unit. What if you push that further? How might a future where every single component could potentially have its own unique, independent quantum truly revolutionize how we design systems? Could that push us even further into truly adaptive, ever-evolving software? Something to think about.
Indeed. What stands out to you, the listener, from this deep dive? What concepts or trade-offs resonated most with your current challenges or curiosities? We invite you to continue your own deep dive into the fascinating and clearly vital world of software architecture.